Imagine a planet so light it could float in water. It's not science fiction, it's Saturn. Of course, we'd need a bathtub the size of the solar system, but you get the idea. Saturn is a planet full of surprises. Saturn's low density is one of its most fascinating features. It's less dense than water, meaning if you could find a big enough pool, Saturn would actually stay afloat. This fact surprises many, as we usually think of planets as giant, heavy rocks. What makes Saturn so light? It's mostly gas. While it has a rocky core, the majority of Saturn is made up of hydrogen and helium. These are the lightest elements in the universe, making Saturn a giant gas ball. Imagine holding a bowling ball and a basketball. The bowling ball is small but dense and heavy. Saturn is like the basketball. Bigger but lighter because it's mostly filled with air. This airy composition makes Saturn much less dense than Earth, which is made of heavier rock and metal. That's why Saturn, despite being much larger than Earth, would still float in our hypothetical cosmic bathtub. Saturn is a gas giant, but don't picture a giant balloon. Instead, imagine a colossal sphere where gases dominate, creating a world unlike any other in our solar system. Saturn's atmosphere is primarily composed of hydrogen and helium, the two lightest and most abundant elements in the universe. These gases are not just floating around aimlessly. They are part of a dynamic and complex system that defines the planet's unique characteristics. Deep inside, the pressure is so intense that the gases compress into a liquid-like state. This transition from gas to liquid is not something we experience on Earth, making it a fascinating subject of study for scientists. The immense pressure at these depths is due to the gravitational forces exerted by Saturn's massive size, which is over 95 times the mass of Earth. This makes Saturn a fascinating mix of gas, liquid, and a solid core. The core itself is a mystery, believed to be a dense combination of rock and ice. This solid core is surrounded by layers of metallic hydrogen, a phase of hydrogen that only exists under extreme pressure, and molecular hydrogen, which forms the outer layers of the planet. The core is thought to be a mix of rock and ice, heavier elements that sank to the center when Saturn formed. This core is crucial for understanding the planet's formation and evolution. Scientists believe that the core's composition and size can provide insights into the early solar system and the processes that led to the formation of gas giants. Surrounding this core is a swirling mass of mostly hydrogen and helium, constantly moving and changing. These gases are in a state of perpetual motion, driven by the planet's internal heat and rapid rotation. This dynamic environment creates powerful storms and wind patterns that can reach speeds of over 1,800 kilometers per hour. The colors we see on Saturn, those beautiful bands of yellow and gold, are actually clouds made of different types of ice. These clouds are composed of ammonia, ammonium hydrosulfide, and water, each contributing to the planet's vibrant appearance. The varying altitudes and temperatures at which these clouds form result in the distinct bands and zones that we observe. These clouds, driven by Saturn's internal heat and rapid rotation, create the stunning patterns we observe. The rapid rotation, with a day lasting only about 10.7 hours, causes the planet to bulge at the equator and flatten at the poles. This rotation, combined with the internal heat, generates complex weather systems, including the famous hexagonal storm at the North Pole, a phenomenon that continues to intrigue scientists. When we think of Saturn, we think of rings. These iconic rings are what makes Saturn one of the most recognizable planets in our solar system. They are a symbol of the beauty and complexity of the cosmos. These rings are what makes Saturn truly stand out in our solar system. Unlike any other planet, Saturn's rings are a spectacular display of natural wonder, visible even through a small telescope. But what are they made of? Ice! Yes, these rings are composed primarily of water ice with some dust and other chemicals mixed in. The ice particles reflect sunlight, giving the rings their brilliant shine. Millions of icy particles ranging in size from tiny grains to massive boulders orbit Saturn, creating the magnificent rings. These particles can be as small as a grain of sand or as large as a house, each contributing to the overall structure of the rings. These rings are not solid disks. They are made up of countless individual particles, each following its own orbit around Saturn. The gaps and divisions within the rings are a result of the gravitational influences of Saturn's moons and the planet's own gravity. They are made of countless individual particles, all orbiting Saturn at different speeds. The particles closer to Saturn move faster than those further away, creating a dynamic and ever-changing system. The rings are incredibly thin too, only a few hundred meters thick compared to their vast width. Despite their immense diameter, the rings are surprisingly delicate and fragile. Imagine a giant racetrack around Saturn. This racetrack is made up of countless icy particles, all moving in harmony around the planet. The rings are like a cosmic dance, with each particle playing its part in the grand performance. That's what the rings are like, with countless icy particles racing around the planet. The movement of these particles is influenced by Saturn's gravity, as well as the gravitational pull of its many moons. The gaps between the rings are caused by the gravitational pull of Saturn's moons, acting like shepherds herding the icy particles. These moons create resonances that clear out paths in the rings, leading to the intricate and beautiful patterns we see. Section 5. Storms and Swirls. Saturn's atmosphere is a turbulent place. Massive storms rage across its surface, some larger than the entire Earth. These storms are driven by Saturn's internal heat and its rapid rotation, which whips up the atmosphere into a frenzy. The most famous storm on Saturn is the giant hexagonal storm at its North Pole. This storm is massive, big enough to fit several Earths inside. Scientists are still trying to understand why it has such a unique hexagonal shape. These storms are not just fascinating to look at, they also help us understand how Saturn's atmosphere works. By studying these storms, we can learn about the composition, temperature, and wind speeds on Saturn. Section 6. A moon for every occasion. Saturn isn't lonely in its corner of the solar system. In fact, it's one of the most fascinating planets when it comes to its collection of moons. It boasts a whopping 82 confirmed moons. Each of these moons adds a unique chapter to Saturn's story. Each moon is unique, with its own story to tell. Some are icy, some are rocky, and each one has its own distinct characteristics that make it special. Some of these moons even have atmospheres of their own, creating mini-worlds with their own weather systems and climates. Titan, Saturn's largest moon, is larger than the planet Mercury. This colossal moon is a world unto itself. It has a thick atmosphere and lakes of liquid methane. Imagine a landscape where rivers and lakes are filled not with water, but with liquid methane. Enceladus, another moon, spews jets of water vapor into space, creating a spectacular display that hints at the secrets lying beneath its surface. These jets suggest the presence of a possible ocean beneath its icy crust, a tantalizing hint that there might be more to discover. These moons are like mini solar systems, each orbiting Saturn in a delicate dance, each with its own set of mysteries and wonders. Each moon has unique features that make it a subject of intense study and fascination for scientists. Studying them helps us understand how planets and moons form and evolve, providing clues about the history of our own solar system. And who knows, some of these moons might even harbor life, making them prime targets for future exploration and study. Section 7. A giant's magnetism. Saturn, like Earth, has a magnetic field, but Saturn's is much stronger. This magnetic field acts like a giant shield, protecting Saturn from harmful radiation from the sun. This magnetic field is generated by the movement of the metallic hydrogen deep inside Saturn. As this liquid metal churns, it creates electric currents, which in turn generate the magnetic field. This magnetic field is invisible to our eyes, but we can see its effects. It interacts with the solar wind, creating stunning auroras around Saturn's poles similar to the northern lights on Earth. Section 8. Exploring the unknown. We've learned a lot about Saturn thanks to spacecraft like Voyager and Cassini. These missions have sent back stunning images and valuable data, revealing Saturn's rings, moons, and atmosphere in unprecedented detail. Cassini even sent a probe to land on Titan, providing us with the first glimpse of this alien world's surface. These missions have revolutionized our understanding of Saturn, but there's still so much more to discover. Future missions might explore the possibility of life in the oceans of Enceladus, or study the strange hexagonal storm on Saturn's North Pole. The more we learn about Saturn, the more we realize how much more there is to know. Section 9. A constant source of wonder. Saturn, with its floating nature, dazzling rings, and mysterious moons, continues to captivate our imagination. It's a reminder of the vastness and wonder of our universe, a cosmic masterpiece that inspires us to explore and learn. Every new discovery about Saturn raises more questions than answers, driving us to develop new technologies and push the boundaries of human knowledge. Saturn is more than just a planet, it's a symbol of the enduring human spirit of exploration and discovery. As we continue to explore our cosmic neighborhood, Saturn will undoubtedly continue to surprise and amaze us, reminding us that the universe is full of wonders waiting to be uncovered.